Hey, this is Leach with Simpson Math, and in this video, I'm going to be going over a little bit of stuff for my business stats students. I'm going to be focusing on some problems from Chapter 3 in our I can't ever say the word right, business statistics, got to really raise your cheeks, a first course by Noreen Sharpe, our third edition. I want to demo just one thing, because this is probably the first video that that kind of might be needed. So here we are on MyLab. If you go to the chapter/course content over here on the side, and then hop down like we're in chapter 3. If you haven't read these things, you might have missed them, but I do have some information here about some PowerPoints that aren't available in the assignment. So if you're wanting to see like a PowerPoint that are from the textbook author, here's that. Here's some other YouTube videos that I found online that go along with our book from a different professor. And then also what I wanted to point out is that I do have, then here is our textbook. So the links to the textbooks, textbook is here by sections. Once you get in, you can hop around at will in the book. But that's a nice spot to kind of start in case if you're needing a little bit of help when you look at things on your own. Is that text. I hadn't really pointed out where that is, so just wanted to show that. So what I'm going to do is I'm going to work through a few of these questions. I'm going to be showing you how I would do them in both in Desmos and in Excel to be able to answering this. Oh, here's a little instructor tip that I have videos. I've actually moved it to the top instead of it at the bottom. So I'm going to show you these and then we'll just kind of work them together. So feel free to hop around, skip around at the different questions, at the different skills. I just kind of want to just demo some of this together. So let's take a look at this. This says, let me make this bigger, like so. All right. This is the marketing team at an internet music site wants a better understanding of who their customers are. They send out a survey to 25 customers using an incentive of $50 worth of downloads to guarantee a high response rate, asking for demographic information. One of the variables is customer age. For the 25 customers, the ages are shown to the right, and complete parts A through D below. I'm going to cheat. I think you can maybe see it behind my head. I have a button that says show completed. I have a teacher button. So I'm going to go ahead and show that get it done so that we can talk about this. So we're going to be making a histogram where the bars are 10 widths, 5 widths, and then what's the difference in this one? Make it use a bar, 5 widths. Oh, and then a relative frequency, and then a stem plot. So I'm going to show you how I would do this in Desmos. So I have Desmos over here on the right. I'm just so desmos.com. I'm just going to open up the graphing calculator version, and let me show you how I would get our data from here over onto Desmos. We'll do this a lot. Personally, I would do this in Desmos instead of Excel. It's just a little bit easier and more accessible to me. Right. So in the by the data, there's a little like picture-in-picture button. So this pops open some options. You can open it in StatCrunch. StatCrunch is a proprietary statistic software that is built into MyLab. You can use it. It's free for you to use as long as you are in this course. I don't make a big deal of it because once you are no longer taking the stats course, you don't have access to StatCrunch for free. So I'd rather be teaching something that you have access to in other ways. But it's a good program. If you're wanting to see someone model it, that other professor that I talked about, those videos, she models using StatCrunch. But I'm going to pick copy to clipboard. So it pops up in the data, already kind of highlights it for us. And right now, it says that the selected delimiter is tab. The delimiter, that is, how is it separating each data value? I want it to be separated by a comma. So I'm going to switch it to comma, little drop-down box. Then I'm going to click back in, and it kind of highlights all for me when I just do a single click. If for some reason it gets off, I can always manually highlight. And then I'm just going to hit Control-C. Or you can right-click copy. And then I'm going to come over to Desmos. And if I just hit Control or Command-V, notice what happens when it puts it in is it auto puts in square brackets, and then it has them separated by commas because I told it to copy the data that way. Now, this isn't the most convenient thing for Desmos because I have a list, but I need a way to be able to reference it. So I'm actually going to come in and edit this and say that these are ages. So I'm just going to say A equals. And so now I can make this be a bit bigger. And so now I've labeled A as a list. So in Desmos, you can use a single letter It is case sensitive, capital or lowercase, to represent a list. You can't use letters that represent things, so you can't use E. I think R is kind of taken. So you can't use things that might represent something, but A is generic enough, we can do that. So let me do that one more time. But the order of operations that I would do, again, I would switch it to comma, Control C to copy, come over to Desmos. I'll go ahead and just type in the letter A. If I'm on a real keyboard here, so I'm just using my regular keyboard, or you could do a pop-up and then the pop-up keyboard and use the on-screen keyboard, but you'll probably have a real keyboard in front of you. So A equals, and then just paste. Desmos will automatically put the square brackets around it. The square brackets are required for Desmos to read that as a list. And again, they're commas because we set it there. We set it to be from MyLab. All right, so now that I have a list of my 25 elements, which is, we knew it's those 25, I just need to ask Desmos to make our histogram for us. Let me scooch this over a little bit. So on my keyboard, I'm just going to type in histogram, Histogram, and then open parentheses. I know that I'm just going to do histogram open parentheses because that's what I use. If you didn't know that, then you can open up the on-screen keyboard, come over to functions, and then scroll down past statistics. We'll use some of those in a minute. And you should see visualizations, and then we're going to select histogram. All that this does, this functions, it's just a shortcut to type in histogram open parenthesis, as you saw me do a second ago. So you can do either way. So you can either pop up the functions and select it, or just type it in. If you misspell it or not sure what the command is, just pull it from the list. Now there are, if you notice, there's in small writing something underneath it. That's Desmos telling us what it wants. It wants to know the data set, comma, the bin width. Well, my data set is just going to be set A. So I'm just going to type in A, and it's already trying to be helpful. And it's already trying to make a histogram. And notice it says, oh, great, I can make a histogram of that with a bin width of 1. So notice it's already given me a default of 1. I'm not going to want 1 because the question says that it wants it to be a width of 10. So let's do that. Actually, first let's find our histogram. So if you look in this entry box, you should see a little magnifying glass with a plus in it. That's the zoom fit tool. So if you click that, it'll take us over to the histogram. And we see it just looks like a bunch of sticks, a bunch of little matchsticks. I want to thicken this up to be a bar of width 10, and where the first bar starts at 0. So I can do that. I want the bin width to be 10, so I'm going to type in comma 10. I'm going to do a little bit zoom fit better. And what it's doing right now is it says that the bin alignment is, my options are center or left. Desmos doesn't let me specify exactly where I want it to start, but it's kind of, I have an option of it to be kind of centered or left. I'm going to choose left because that's going to kind of line us up a little bit closer to what is where it's starting at 0, so starting at kind of that smallest value, and it tends to kind of pick numbers that make sense. So this does a pretty good alignment matching, and actually is exactly what we want. It's starting at 0, 0 to 10, 10 to 20, 20 to 30. Recall like the data value 30 here would be here. I think you can see my mouse. Yep, so it'd be here, but it's actually representing in this taller bar. The first one, number 20, that number 20, this is 0, 10, 20. 20 is on the dividing line, and it's in the upper bar, the one above it, this one from 20 to 30. So if it's on a dividing line, it's in the bigger bar. That's kind of our default because most things, like if we had a 0 value, I would want the 0 to be in the 0 to almost 10 bar, not in the negative space. So that's kind of why we default to that. So we can just see which one that matches up to, and we see that that is D. Now, if I'm working this problem and I'm trying to do this efficiently, maybe on a quiz or a test, I'm honestly probably not going to come to Desmos to answer this because take a look at this. So it's on this particular question, it's multiple choice. And I see that 2 of my options have nothing between 0 and almost 10. I'm going to look at my list. I see that there's nothing between 0 and almost 10. So I can immediately get rid of B and C. All right, so now I just need to compare A and D. Well, A and D both have 2 people in ages 10 to 20. Okay. And I see a pretty big difference between the 40 to almost 50-year-old range, where the right answer has 6, this wrong one has 9. So I could just kind of come through this list and count to see how many 40-year-olds there are. I'm just going to work vertically. Nope, 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 nope. There's 1, 2, 3, 4, 5. Did I miss one? 1, 2, 3, 4, 5. There he is. 6. Yep, I didn't. Was missing that 48. So just counted the six 40-year-olds, which is what that bar is representing. I didn't have to do any of this mess. And I know the answer is D, and that's because of its multiple choice. But here I wanted to show you how you could use technology to actually produce that the histogram and also getting that data over. So similarly, if we wanted to do the histogram with bars bin widths 5 or bar widths 5, so I'm just going to change this to be 5. Can zoom fit it again, so it kind of zooms in on it. And we see, so this bar is 0 to 5, 5 to almost 10, 10 to almost 15, 10 to 15 to almost 20, so forth. So when I do, let me make my phone be quiet, 1 sec. Notice we can again see which one matches best, and it is that B. Again, I would do a similar process of just kind of a process of elimination to see which one matches, because it is just a multiple choice question after all. One thing that's important between with what B and C is making here, B is a histogram, C is a relative frequency histogram. So it's a graph of the percentages or the proportions. What's important to note is that the shape is the same. So notice that the right answer here is B, and then here on the relative frequency histogram at C, they have the same shape. What's changed is the Y scale. So instead of this tall bar going up to 6, the tall bar is going up to 24, probably 24% of people. Because 6 divided by 25 would be that 25-ish, almost 25-ish percent of people, 25, 24, that's where that bar is going. All right. All right. And lastly, a stem plot. So this stem plot, notice how it's using 10s as the stem. That is back to what we had when we had our histogram at 10. So notice we have nothing in the zeros. We have 2 people in the 1s, 7 in the 20s, and notice how they're written in order, all those in the 3s, all those in the 4s. So it basically corresponds and matches back up to what we saw here with letter D. All right, so that's that one. Let's move on to, I'm going to do number 3 on your homework. Because this one is about doing mean and median. I did skip going over on Excel. Making histograms in Excel is annoying. I might show in this next one how to do it in Excel. But in here. Okay, so let's take a look at this one. So same question, different set of data, different question. So same main stem. So the marketing team, 25 ages. Then we went ahead and given us a graph of the histogram. How nice of them. So the question is, would you expect the mean age to be smaller than, bigger than, or about the same size? If we take a look at the shape of this histogram, because the shape of this histogram is roughly symmetric, we would expect the mean and the median to be pretty close to each other. And so that's what this option here is. Recall that if the distribution is skewed to the left, skewed towards the smaller values, those smaller values are going to pull that mean down, make that mean be smaller. So if it's skewed to the left, the mean should be smaller than the median. If it's skewed to the right, like what we often see with like people's salaries, annual household incomes, the really, really rich will pull the mean really, really high. That's where we use the median household income. So if you have a skew to the right distribution, the mean would be bigger than the median typically. But when it's reasonably symmetric like this, the mean and the median should be about the same. And when we kind of spy the answer, we see that they are the same. So let me clear out this stuff. And let's do this problem again on Desmos, and then I'll show you how to do it on Excel. So similar process. I'm going to click the little pop open, switch to copy to clipboard, switch it to a comma, click, Control or Command C, come over here, pick any letter. I'm just doing A equals, and then paste. So there's my list, and it knows that it's letter A, so I could name it and use it. So again, I could do the histogram of A, and it looks like it's bin width 5. Oops. So we could do this, and we see how this matches our graph. Cute. but we're not needing it because they already gave it to us. But what it's wanting is the mean and the median. So the command for mean in Desmos is mean, and the command for median is median. If you didn't know that, you could pop open the functions, scroll down to statistics, and you'll see mean and median living right here. So I could just select mean, and notice it just types in MEAN, open parentheses. It's the same thing as just doing that on the keyboard. But the mean of what? The mean of my data set A. Notice if I change this to B for some reason, then I would need to change my mean to BB. That's just a nice little naming system so you can have multiple lists going on at the same time. So my mean of A is 31.24. Make sure to follow the almighty blue text. I don't see any blue text over here, so that means just type in exactly what we get, 31.24, no rounding. And then the median is this 31. So recall, the mean is the physical balance point. So if I had all these data values laying, like if they were little like blocks or cubes or something sitting on a on like a little balance board, the physical balance point of this data set would be at that 31.24. And the median, that's the number in the middle, since there's 25 data values. If I count, there's like 12 below it, 12 above it. This 31 is the 13th number in that list. All right, let's do this in Excel. So I'm going to go back, instead of having to type all this into Excel, we can just hit open in Excel. It'll open up, it'll download it, and then we can open it up. This was an Excel file from something I was practicing something a second ago. All right, I'm going to click a button. This is enable editing so that, oh, now it moves around on the screen. How lovely. Move Excel down so you can see all of Excel. Okay, there we go. Make this a bit bigger. All right, so it hasn't done anything fancy. It just has these 25 numbers, and notice it's even in the same order vertically right there. So what I want to do, I want to show you how we could get a histogram, even though it's annoying. Let's do a histogram and then mean and median. So to do a histogram, I'm going to highlight these 25 numbers, go to insert, and then this option in the middle is more of a statistic chart. The options there are a histogram or a box plot. I'm going to pick a histogram. I don't like how they do this because they don't have it sitting on a number line. They have these like intervals, which are a bit dumb and annoying, and also like have it be set up weird, but we can find a way to adjust this. I gotta remind myself. I didn't practice this a second ago. Not the gap width. Let me make this bigger. How do I adjust the bars? Not select data. I think I click on the x-axis. Yes, so I click on the x-axis. So you can see there's kind of a bounding box around the x-axis. Then over here on the far right-hand side, we see some options. It says, what do you want to do with these options? And I want the bin widths to kind of match what we have in the picture. I want them to be 5. So notice I could say I want them to be like the number of bins or the width of the bins. Can I tell them where I want it to start? No, that's weird. I thought I could tell it to start at like a small number, but it didn't like that. Like I said, I don't like. So anyway, so here's an idea of how we can do that. So we notice how it's choosing to start at the smallest at 14 instead of starting at basically at 0. So it's going 14 to 19. Notice how it is, for some reason, it is choosing to include the 19. So it's 14 to 19, including 19, then almost 19 to 24, because it's using the interval notation. So even that's a little bit different. Like I said, I personally like doing it in Desmos. All right, So that's a way to do histograms in there. And again, the x-axis is a bit annoying because I wish it was. Let me just play for a second. I don't think, yeah. These aren't doing what I want to do. Okay, so now what we're here for is now let's talk about how we can do the mean and the median. So to get the mean of 31.24 and the median of 31. So recall in using Excel, anytime you want to do a function, you start with an equal sign. So I'm going to pick some box. I'm going to just label this mean and label this median. So that way I know what I'm getting. I'm going to put the mean next to it. So I'm going to say equal to, and that starts my function. And then the mean function is not a function in Excel. There's those three that you're seeing on the screen are not the average, that arithmetic mean. So the arithmetic mean that we're looking for is just the word average. So if you start typing average, you'll see some options. You can arrow down or arrow up. I believe you can double click. I often just hit tab, and that fills in the rest. So average of what? So notice how the tips are saying number 1, comma number 2, comma number 3. Well, I don't want to type in the numbers because I already have the numbers right here. So I'm just going to type, I'm just going to literally just now highlight A1 to A25 and close my parenthesis. Another option that I could do under average is, since I don't have anything else in column A other than just this data, I could just click on column A and it's going to say go from column A to column A, and that's going to give me the same thing. Let me show you all what that is. Let me print these two. All right, so I'm just showing you a little hack is just to show you what is in those cells. So this is just printing that text there. So what's here is the formula text for this. So average of A1 to A25, or just average of A to A. Then for the median, it's a similar thing. So it's equal to median. So MEDIAN, double click on it or hit tab. And then again, we can highlight the cells that we want to find the median of. Or since like I said, the only thing that is in Excel, fill down. The only thing that is in Excel, in that column is the data that I want. I can again do the median of just column A. So column A to column A. And then what I'm doing here, again, I'm filling, there's a thing called fill down that you should be familiar with in Excel. So I can fill down so that way you can see what that is. So median of A1 to A25, or just the median of column A, they both work, and we notice we get that mean. Now again, if I was a student in this class and I was needing to answer this, I would just do it in Desmos. It's a lot faster, for me at least. All right, I'm going to do the next question. All right, so this one is asking, it's same situation, same context, but it's wanting Q1, Q3, and the IQR. So this is dealing with finding it using technology. That technology is wanting, like I think this is specifically wanting Excel usually. I think it'll let either happen, and then the 2-key method, which I'll talk about, and then the using that to find the IQR of the 2-key method. And then we'll also talk about the standard deviation. So let me get my data over here. So copy to clipboard, switch it to comma, click, copy, delete these things, A equals paste. All right, so there's my data. Let me just start with the standard deviation because that's easier to kind of talk about real fast. So I want this standard deviation. I'm going to open up my functions list and scroll down under statistics, and we'll see two things that look like standard deviation. One is STDEV, that's short for ST for standard, DEV for deviation. And the second one is STDEV with a P. The P is a population. The one without the P is the sample standard deviation. Notice this is a sample of 25 customers, so we should be using the sample standard deviation. Remember mathematically the difference, the sample standard deviation is dividing by n minus 1, whereas the population one is just dividing by n. All right, so then I want to find the standard deviation of my data set, and that's it, so 9.921. So recall what this number is representing. This is the typical distance the data values vary from the mean. So roughly on average, the customers at this store vary about 10 years away from the mean. So wouldn't it be shocking to find somebody 10 years older than the mean or 10 years younger than the mean? So about 9.9 is the typical distance that our ages vary. So this particular internet music site has a wide variety, fairly wide variety of ages. All right, so now let's take a look at doing our Q1, Q3. So to get the quartiles on Desmos, you could just come to statistics and type in quartile. Be careful to not pick quantile. That's something else we will not be using in this course, but quartile. The quartile wants two things. It needs the data set and the quartile that you're asking. So I'm going to type in A. It's still going, I need something else because it needs to know what the quartile, quartile 0, 1, 2, 3, or 4. So quartile 1, this is the same thing as the 25th percentile. So I'm just going to type in comma 1. And this is our 25th percentile or the first quartile. For the third quartile, it's the same thing. I just literally just copy and pasted and changing it to be quartile A, comma 3. So notice here, I'm getting the results that this is looking for. It's happy with 41 or 39. So 41 is returning that. I bet if we did this in Excel, we would get maybe the other method. I bet we might get the that 39 maybe. Okay, so let's take a look. So let's switch to copied, nope, not copied to clipboard. Let's open this in Excel. Maybe, here it comes. Enabled editing, moves it around the screen for some reason. All right. So with this, I'm going to get our quartile. Specifically, I want quartile 1 and quartile 3. So I'm going to type in that I want Q1 and Q3. That's just to help keep me organized. And then I'm going to start typing in quartile. So notice when we have quartile, we have three options. We can have quartile.exe or inc or quartile. Let's actually compare these three. Let me move this down. I'm going to do quartile dot exe, right? Yep, for exclusive. I'm going to do quartile dot inc and then just go to regular quartile. So the third quartile, that is a legacy one that they don't really want you to use. They just have it around for compatibility purposes. So let's go ahead and do this. So I want the quartile. I'm going to do quartile exe. This says returns a quartile of the data set based on the percentile varies from 0 to 1 exclusive. So it says, as two questions, says what's the array and then which quartile do you want? So again, my array is column A, or I could do A1 to A25 and then comma, and then it says which quartile do you want? It even gives you your options. I'm just going to do the first quartile. And so here I do get 26. And then I'm going to just fill this down. And the reason that I can fill down safely is because I did the column, so I knew that the column wasn't going to change. I'm going to change this to 3 for the third quartile. And we also get 41, so that's nice. Then the other one, let's do inc just to see what would happen. This is the inclusive, so it's including those inbounds. Again, A1, still get 26. And then when we do the third quartile, notice this time it gives us that 39. And then just out of curiosity, what do we get for our for regular quartile? $26 all the way down, but then third quartile, we get this 39. So let's talk about what's happening, where this is coming from. And then we'll talk about using the two-key method and why it's that 39. So I'm going to highlight column A, and I'm going to tell it to sort. So I'm going to come up to, maybe need to make this a little bit bigger. Here we go. So I'm going to come to sort and filter, and I want to sort smallest to largest. All right, so now that I have this sorted, You can make this a little bit smaller. Let's just start counting. So if I was to be doing this by hand, since I have 25 data values, oh, I'm gonna fast open my book just to double check the Tukey method. Because Tukey either includes the median point or excludes it. I don't remember. I don't want to be wrong. So okay, so for the Tukey method, we will be including the median for each half instead of excluding the median. Our technology tends to exclude the median if the median is odd. So either will work. All right. The reason why it's called Tukey method is because it's named after statistician John Tukey, who kind of was the creator of the box plots. All right. So what's going to happen here? Let me add in a row here. So if we take a look at our data here, this is in order from from 1st to the 25th, 11 down to 48. The middle data value is going to be the 13th data value, this one right here. This would be the median. So if I also asked for the median, it would be this 32 here. If I count the first 12, it's this 11 through 31. The bottom 12, it's the 33 down to 48. This is the middle. I get there because if I take 25, cut in half, I get 12 and a half, and then I just round up. So this right here is the median. All right, what technology does is it will often ignore this median, and then it will find the median of the lower half here. So if I took a look at the median of this lower half, it would be of these lower 12 things, it would then be the average of these two. Notice how I have 39 and 43 for my 6th and 7th position in this upper half. So Q1, how it's getting this 41 is because it is averaging this 39 and this 43. Also, sometimes with Excel will also return a different value than something like your TI calculator or Desmos, because Excel will also sometimes it'll sometimes interpolate, so it'll even produce a different thing. So notice if I average 39 and 43, we get 41. That's where that's coming from. But notice here, I have two 26s, so since I'm getting those two 26s, 26 average with 26 is 26, so that's where we get the same result all the way across here. The Tukey method says, no, let's not look at these. Let's not find the median in the bottom half. You're going to include this median. So if I take a look at this the bottom half right here, so 11 to 32, count the median, include the median. So looking at these 13 data values, which of these is Q1? It would be this, the 7th value, this 26. That's Q1. Then include the median again, but this time in the upper half. I keep flipping my upper and bottom, sorry, because this is on the bottom of my screen, but it's the upper half of the data set. So now I'm looking at these 13 data values, and the number in the middle of these is the 7th one right here, which is this 39. So this is the Q3. So that is the Tukey method specifically. The Tukey method, always, if the data values are odd, we will include the median. So always use the median. The technology tends to not use the median, or even specifically, they might even do some interpolation as well when doing that. So that's the Tukey method, and so that's the difference in those two things. So this is kind of by hand, and if it's odd, then you include the median. If the data set happened to be even, then there would be no difference in the traditional technology method and Tukey. Excel, again, might do some interpolation with the even, so then there could be a difference. But under Desmos would not have a difference of the Tukey method versus technology if it was even. All right, so then now we need to find the IQR using part B. So not the IQR from Desmos, but the IQR using part B. So if you recall that the IQR is the interquartile range, that's Q3 minus Q1. So I'm going to do this 39 minus the 26, and that's how you get the 13. Just a side note, let me show you one other way to be able to get the a few ways to get the IQR. I'm not going to get the 13 result because this is not the two key method over here, but I could literally just say quartile 3 minus this quartile 1 formula. It will produce the IQR, which is this 15. Another nice way to be able to produce these the quartiles is to get from the bottom of my statistics options, there should be a stats option. So if you do stats of A, stats is going to return what we call the 5-number summary: minimum, Q1, median, Q3, maximum. One more thing, just while I'm talking about rambling about quartiles, and I'm sure you're like, yes, you are rambling. Notice if I have the 0th quartile, that's just the same thing as the minimum. The first quartile is obviously Q1. Second quartile is the median, because if you have two quarters in your hand, that's 50 cents. And the fourth quartile, if you have 4 quarters in your hand, that's 100% or 100 cents. That would be that maximum, that 48. All right. So I think, standard deviation. So on Excel, let's talk about getting the standard deviation real fast. So let's do standard deviation. So equal to, then if you're like, I don't know what it is, just start typing ST. Oh, I see a whole lot of things that look like standard deviation. I see standardize. I see standard deviation with a P and with an S, and then some other things. I even see some legacy standard deviation things. So if you know that there's a sample standard deviation and population standard deviation, it's going to be these two. Again, don't use the legacy ones. Use the .p or .s. So since we're using, this is a sample, we're going to use the stdev.s. So double click or press tab. And then just like the means or the medians, just what's your list? So my list is this list A. It doesn't matter if it's sorted or not. And we get this 9.921. And there we go. Again, obey the almighty blue text. Blue text is 3 decimal places. So make sure to do 3 decimal places, by golly. All right. Let's move up to number 6 here. So now we need to find the z-score for these things. So we again, we have a survey for the customer's ages. So we want to standardize the minimum and maximum ages using a mean of 31.88 and the standard deviation. And then we want to find the z-score. So in this particular case, they have given us the mean and standard deviation. If they didn't, I want to model what that would be, what that would look like. So again, copy, switch it to comma. So here's my data set in. Just to verify, the mean of my data set is at 31.88 and the standard deviation. Notice how the font here is italics. Once I type in something it knows, like STDEV, once I add that V, it goes to normal text because that's Desmos going, oh, I know what that is, but it does want the open parenthesis. And here's our 9.641, right? So that's our mean and standard deviation. I'm going to use those data values to produce our z-scores. So recall that the z-score is x minus the mean divided by the standard deviation. I'm just going to do it here in Desmos because it's nice and visual. I'm going to first start with my fraction. So if you just press the slash by your shift key, the one that's on the question mark, or come over here on the on-screen keyboard and just do division. So again, I'm going to write out in words just so you can see. I'm going to do the x minus the mean over the standard deviation is what I'm going to be doing. Now that's not going to work mathematically because those aren't formulas. I just want you to see it on screen. So I'm going to do my division. My x would be my minimum. So you could look through and find the minimum, which is 11, but I could also just find the minimum of my data set, which is that 11. So again, my fraction division. So it's 11 minus the mean of 31.88. And we're going to use the decimal places that they gave us because we didn't have to do find the more accurate ones. And then divide by the standard deviation of 9.641. And so the z-score is negative 2.166 right into those decimal places. And then similarly for the maximum, the largest data value is 47. It's only 25 data values, so it's not too hard to find the largest is 47. or you could use the max function, and we're going to do the same thing. So 47 minus our mean of 31.88, then divide it by 9.641, and we get 1.568. So just a reminder about what these things are representing. This is saying that the minimum data value is 2.1 or 2.2 standard deviations below the mean, under the mean. I know it's under the mean, 1, because it's the minimum, 2, the z-score is negative. Our maximum age is 1.56 standard deviations above the mean. So what we're doing is we're using the standard deviation as a ruler to be able to help us find where these things are. So if I was to have a ruler that was 1 standard deviation long, it would take almost 1.56 of those rulers to get to the maximum. It would take 2 whole rulers plus a little bit more to make it down to the minimum if I'm starting at the mean. So it says which one is more extreme, the min or the max? The minimum, because it's further away from the mean. And then this is kind of a little working back question. How old would someone be if with a z-score of 3b? Let me take a little snip so I can run on the screen real fast. So we just need to do a little bit of algebra to be able to solve this. So recall our formula is z equals the x minus the mean divided by the standard deviation. So in this case, if the z-score is 3, so my z is 3 equals, I don't know what x is, minus the mean of 31.88 over 9.641, which is our standard deviation. Sorry if it's a little messy, I'm writing with my mouse. All right, so now I just need to do some multiplication. So I need to solve for this x. Sometimes this freaks people out with all these decimals, so my tip would be, you would know, I'm sure if you're in this class, you're in my business stats class, algebra, either business math or college algebra is a prereq. But it said 3 equals x minus 1 over 2. Solve. Everyone in here should know what to do. We'd multiply by 2. We'd get 6. 6 is x minus 1. Add the 1. And we get 7 is x, right? That's the same thing that's happening over here. We just have decimals now. All right, so now I'm going to multiply both sides by 9.641. 9.641. Searches frantically for a calculator. Here we go. Oh, I guess I have it on. I should just pull up the on-screen calculator. Duh. So then we have 3 times 9.641. We get 28.923. That equals our x minus 31.88. And then I'm going to add this 31.88. Notice it's the same math that we would see over here, where we're adding that 1 over. So I'm going to come back to my calculator and say plus 31.88. And notice we get our 60.082. I got 083, rounding error. So 60.083. Let's see if it would take, oh yeah. So it's accepting one of those answers. I don't know why that's off a little bit. All right, yay that. What's next? Did want to cover number 7. Okay, so let's talk about box plots. Actually, sorry, rewind, go back. My numbers might be a little bit off because I just had it reload the question. But I want to talk about getting this from in Excel real fast. So my numbers will be a little bit different because I just had the problem reload. Oopsie. It'll be okay. So I'm downloading this file from Excel, opening it up, twiddling my thumbs. I promise I have a fast computer. All right. So again, they're giving us the mean and standard deviation, but I want to show you what if they didn't give me the mean and standard deviation, how to do this. So I'm going to say, here's my mean, here's my standard deviation. So let me get my formulas for the mean and standard deviation. So equal to average, tab, all the A's, all the A's, enter. Then standard deviation equal STD, go down to the S, tab, all the A's. For your benefit, I'm going to type in something called formula text, just so you can see what I use for those formulas. It's not a thing that you need to do, just so you can see what I have in there. All right, so now for the z-score formula, so I'm just going to say z equals, actually rewind, I'm going to make a little formula for us. So I'm going to say, just type in a value, I'm just going to type in x, and then I'm going to highlight it yellow, as in this is a thing I'm just going to manually type in. So now for my z, I'm going to type equal to, and then I don't have a nice handy dandy little fraction numerator and denominator clear thing, so I have to use parentheses to clearly denote the numerator, because both the x and the minus mean are being divided by the standard deviation. So rather, the difference of those two things is being divided by the standard deviation. So I have to open with parentheses. So I'm going to do open parenthesis. I want my x value, so it's going to be whatever's going to go here, minus the mean, and then close my parentheses. So notice what I'm doing here is when I'm clicking, it's referring to that problem. Let me actually back up for a second and say that my x is 10, just so I have something in here. So let me do this again. Equal to, open parentheses. I'm just clicking in cell D3 and it's putting in D3. If you can tell that this is a little blue running ants, and this D3 is labeled blue. Minus, now I'm going to click on the mean cell. This mean cell is this 32 right here, so cell D1. I'm just putting D1 right here. Notice the running ants and the handles are now red, and this D1 is red. Close your parenthesis. Now I want to do divided by, so I'm going to do the slash that's on the parenthesis by the shift, and then divided by the standard deviation. Again, this is now color-coded purple. Press enter, and then here on this standard, this is a negative 2.30307, and that's the z-score for a 10. Well, I'm going to find the minimum, and I see that the minimum is 11, and if I wasn't sure, I can do equal to min of this list, and we do get 11. So I can just type in 11, and it will automatically update the formula. So this formula is doing 11 minus 32 over the standard deviation. Now, probably in hindsight, really, if I'm working this problem, I'm just using a calculator. I'm not even really using Excel. You could do this problem just with a dummy calculator. I'm being a little bit extra for teaching purposes. And then again, for my maximum, the maximum equal max of these data values. Oops, I didn't hit tab. Equal max tab. There we go, of these data values. And so now I can just put in that 48 and it will update it. All right, so you're seeing a little bit of the power of Excel, so you don't have to type things in. You can kind of build up little formulas. And what's nice about this is this particular thing, if let's say 5 more people walk in and you want to be able to find the new mean. So I'm just going to make up a few numbers. So we have a 38, a 28, a 25, a 19, and a 42. So notice the mean and standard deviation have updated. They're not the same that they were a second ago. And I intentionally didn't put a number bigger than my max. But then I can now change my, update my X, and this thing updated live. Or if you realize you mistyped that 39 and that 39 should be 19, notice those numbers will change. All right, enough of that. Let's move on to number 7. So this one's about box plots. So let me clear this out. Copy to clipboard, comma, copy. Now, admittedly, they're giving us enough information. We really don't need to type in or to do Desmos for anything, because they're giving us Q1, median, Q3, and the IQR. So we don't really need to do anything with here, but I'm going to go ahead and show you how to be able to do this. So if I want to just make a box plot, we can just type box plot of A, and here it will produce the box plot there. I'm even going to zoom in for us a little bit there. And you should be able to see where those numbers are lining up. These 5 numbers line up with our 5-number summary. So stats of A. So this number is 18. This is 27, 32, 38, 48. Now, this is a little bit off because this problem is clearly wanting us to use the 2-key method. So it's giving us the IQR. So it's giving us Q3 of that 36 instead of the 38. So we'll use those numbers, but I just wanted you to be able to see where this comes from. Notice if we had an outlier, if an outlier was showing up, I'm going to add a number that would be probably an outlier here, so like 1 comma. So notice here, this open circle right here at 1, that's saying that we have an outlier at 1 in that case. So if I had outliers, let me move it over so you see a little bit clearer. There we go. So then we would see an outlier, but there are no outliers, so we don't see any graph. So now how would I work this problem here with the given information? So recall that the 5-number summary, that the box plot is basically a graph of the 5-number summary plus additionally outliers if they exist. So I'm looking for my smallest number. The smallest number does appear to be 18. I'm looking at my graphs, and I see that this letter A, smallest number is like at 14. That's not going to cut it. This is at 18. This has an outlier at 18. This is 18. So I can get rid of A because the outlier goes too far down. What probably happened here is they're applying the outlier rule incorrectly. So let's talk about the outlier rule. The outlier rule is we take 1.5 times the IQR and you add it to Q3 and you subtract it from Q1. I use my shoulders as a bit of a mnemonic device because I think about when you're a kid and it was laundry day, laundry was folded, and you have pretty folded laundry on the couch, and you need to pick it up and take it to your room. By golly, you're going to do it in one step, aren't you? So let me switch to my camera. So if you're going to try to pick up your laundry, you're going to stretch your arms out really, really wide. I'm going to leave the camera if I do, but stretch your arms out really, really wide and try to grab everything that you can, right? You're not going to do this, right? You're not going to try to pick up the laundry like this, or like this, or like this. That's weird, right? So your right shoulder, you're going to go higher. Left shoulder, you're going to go lower, right? So that's the same thing that's going to work with the outlier rule. What we do is we take 1.5 times the IQR. Why 2-key pick 1.5? Well, because he said 2 was too big and 1 was too small. So he just settled with 1.5 and it stuck. So what we're going to do is let's find 1.5 times IQR. And I'm going to use their numbers. So they're giving us Q3 is 36 minus 27 for Q1. And so we know that our IQR is 9, which they also gave to us. So if I do 1.5 times that 9, I get 13.5. So the idea here is that our boundary is, let's take Q3, I'm going to add to Q3, and then I'm going to subtract from Q1. That's why I did the laundry pickup thing. The biggest gets bigger, the smallest gets smaller. Don't do any weird kind of pickups. So the 36 is my Q3. I'm going to add to that 36, 13.5, and I get 49.5. Notice that's where this whisker in A is trying to take us for the maximum is up to 49.5. And the minimum, if I do 27 minus our 13.5, it's taking us to about 14 or 13.5. We do not graph these numbers. These numbers are just kind of imaginary boundary lines. Anything beyond that boundary line is an outlier, and everything within it is regular. So in the laundry analogy, inevitably it's a sock that you'll miss, a sock or two that'll miss and roll away. Those are the outliers. Everything else that you grabbed, all the laundry that you pick up that you took to your room that I'm sure you put into your drawers, were just a regular data value. So anything beyond that are outliers. We don't graph these things because they're not data. We graph actual data. So that's how we know that there's no outliers. My minimum number is 18, and this the lower boundary line for outliers is at 13.5. My largest number is, my maximum is 48, and the biggest number that's the biggest number, and my boundary line, my fence for the upper outliers is past that 48. So I know I don't have any outliers. So looking at A, they're going to these boundary lines. That's wrong. C and D have outliers. My maximum and minimums aren't outliers in this case. So that's why I know that B is the only thing left. Additionally, I can check and see that Q3 is 36. These are too high. Q27 is Q1. These are too low. So that's also why I know that it's B. So are there any, does a box plot nominate any outliers? No. The reason why this is saying nominate here is because our book likes to take an approach of don't just blindly follow the rules. So if something is, it might be past the outlier, but if there's a lot of other dots that are real close to it, then maybe it's not an outlier. Maybe there's nothing unusual with it. Because again, 2Q was literally that flippant of 2 was too big, 1 was too small. So we just kind of settled with 1.5. More advanced statistical programs will use, will give us the option to be able to adjust that number off of 1.5. So that's why it's saying nominate any outliers. And so then what would be considered a high outlier? Anything that's more than this 45, 49.5. So notice we didn't need to use technology for that, but we could help us a little bit to get us started. But they are using the 2-key approach. So that's why we couldn't quite use this approach anyway, using the technology. All right, 7, 2 more. Let me hop over to 15. Oh, that was it, I think, right? Oh, no, not that one. This one. I didn't write this number down, but I did intend to do this one. Okay, so this one and plus 2 more. Okay, so this one's a bit tricky. One, surface level, if I wanted to be able to answer this question, I don't need to use technology because it's a multiple choice. We can kind of guess and check. So one, I should be able to eliminate B and C quite quickly because if I'm looking at my data set here, I'm seeing that males are, pardon me, I'm seeing that males are the younger of the ages. This list is a little bit hard to look at. It's the age and then it's gender. Imagine there's a nice thick line right here. So this male is 20 years old. This 28-year-old is male. This 31-year-old is male. So notice there's an 11-year-old who's a male, a 14-year-old, and none of the female are that young. So that's why I know that when I'm looking at the box plot here, that it can't be B or C because the ages and genders are kind of swapped. Because that 11-year-old, I'm looking at the 11-year-old male, is not seen down here like there are on A or D. And then lastly, you just got to see if there are any outliers. And I know that I don't need to do, that there's not going to be an outlier here, just visually. Remember that this is, the width of this box, or in this case, the height of this box, is the IQR. So if I take the height of this bar, and then move it below, take the height of this bar, multiply it times 1.5, and then move it below this line, I would be down here. So I know that there's not going to be any low outliers because this 11 is just about kind of 1 IQR or so below that mean. So just from visually speaking, I know that those are not outliers because remember, my outliers have to be at least 1.5 IQRs below Q1 or above Q3. So that's why just process of elimination, it's A. So now, the one problem with this in Desmos, if I wanted to do this on Desmos, if I said copy to clipboard, this is not going to copy very nicely. Like it's just not going to work. I can't just grab just a few of these. I can't just grab the ages and move them over. So yeah, I'm going to show you just a little bit of Excel manipulation on how you could be able to manipulate this data in Excel. If you really, really wanted to be able to do this. I swear, once I click Excel, it then pops up faster. Yeah, so maybe I click Excel instead of wait. Huh. Anywho, all right. So let me enable this editing go away thing down there. All right. So what I would do just simply is first I'm going to sort my data. So I'm going to there's 2 ways to do this. We could do a filter or we could do just the sort. I'm going to just turn on, oops. There we go. I'm going to highlight these, come over here to my sort and filter, move this down a bit so you can see sort and filter. Sort and filter. I'm going to just say filter, so it turns on my filters. So I don't have to pop up the dialog box. I can do this within here. So it creates a little table around here. So I can sort it by age. So I click on this little arrow right here, sort by age, smallest to largest. So now it's sorted by age, smallest to largest. And then I'm going to sort by sex, smallest to largest. So it's going to be females and then males. I'm sure I'm going to do biggest to smallest, males and then females. So that way it's in the order that they have it on the screen, you know, the misogyny. So by me sorting the age first, now these ages are in order. If I hadn't done that, I'm going to undo. If I just sorted gender first, notice that these aren't sorted. They don't need to be sorted. It just might be a little bit nicer. Since you have Excel here, just go ahead and have it be sorted by age and then by gender. So that way it is nice. So now you can maybe even easier make those calculations. Let me show you how we can do this in a box plot. One weird thing about the box plot is that when I was practicing with it, it was wanting the categorical variable first. So I'm highlighting column A and just dragging it over. So that way it is, we have the categorical variable and then the quantitative variable. So with these highlighted, I'm going to go to Insert, my statistics charts, and I'm going to pick box and whisker. And when I did it the other way, it wasn't working easily. So by switching and putting the categorical variable first, it does it. And so now that we have this, so here are my males, here's my females. It will do outliers. You might have to go do an option or something to be able to see the outlier for it to be on or not, but it should. I think I can choose for it to have outliers or not, but it should automatically have the outliers showing up. But there aren't any outliers as well. You could further do the calculations like we did in the last questions to verify 1.5 times IQR is not 1.5 times IQR minus Q1 or below Q1 does not produce any outliers. Additionally, if you want to do this in Desmos, now that you have it sorted, I can highlight this, copy, and come over to Desmos, clear this stuff out. This is males, so I'm going to do M equals paste, and then highlight the females, copy, and Desmos will kind of auto add in those commas even for us. So I'm going to do F equals for females. So here's my 10 males and 10 females. And now I can do box plot. So I can either just type in box plot, open parentheses, or scroll down under visualizations, box plot. So box plot of M, and then box plot of F. Now they do look on top of each other. I'm going to move the M up. I'm going to move it to be, let's have it be at 2.5. So this is just offset. Where do you want the center of that graph to be? So just scooched it up. You can make it be taller, do the outliers or not. So now you can see, you can kind of compare those two. So either of these graphs are the one that we provided. We can see that the age of the company's female customers are generally higher than the company's males. And the box plots show that at least 3/4 of the company's female customers are older than all of the males. So what's that saying here is if you look at the box plot here, 3/4. So remember that that these box plots are graphs of the 5-number summary. The 5-number summary separates the graphs into 4 25% chunks. So this chunk up here is 25%. This chunk, this upper part of the box is 25%. This bottom part of the box is 25%. So 25 plus 25 plus 25 is 75%. Notice that 75% of the company's females are older than all of the males. I can't say that with certainty in some other respects, just like where this line lands here is just seems to be just a little bit above this median. I don't know where these men are stacked up if I didn't have the data to look at. So I can't kind of with confidence say that all the women are older than 75% of the men, because I don't know, or I can't say like 55% of the men. You can't kind of find an area. I can't say 55%, even though it looks just a little bit above there, because I don't know where those men are in this box. I can say that all the women are older than, it looks like older than 50% of the men. All right. So that's that. I wanted to show you how to be able to manipulate that data around. And then I'm wanting to do this one. I just want to show you this one. There's no need for me to do any fancy things. Just want to talk about it real fast while I have your attention. So this question bothers some students. This is an ogive or an ogive. I never remember how it's pronounced. So this is a graph of this percent below. You can think of this as a percentile or a relative frequency. So the median would be this 50% mark. The Q1, lower percentile Q1 would be the 25% mark, 25% below. Upper quartile is the 75th percent. So let's talk about this median here. So if I come over to the median, you should be able to see my mouse. The median would be the 50% below. I'm going to come over until I see a dot, and then I'm going to go down, and I see that it's just a little bit less than 36. Estimate, notice this is 35.5 would be this dot. So this is like maybe 35.9, turns out it is. Now I want to show you how forgiving this question is. It would accept 35.6, 35.7, 0.8, 0.9, or 36 itself. This dot is clearly not equal to 35.5. 35.5 is this line right here. This is well above that. So it's being very forgiving that it's allowing that wide range. So it's allowing anything bigger than 35.5 and up to including that 36, because it's also clearly below that. So it's not trying to get you on those. The directions do say 1 decimal place. It's making sure that you're landing in the right spot. So notice that's how you can find the range in IQR. The range is this biggest dot, the 100th percentile, so about 37.8. The minimum is this 31.1. Do that subtraction as best you can, and you should get about 6.7, and they have a bit of a wide range for appropriate answers. Similarly for the IQR, this quartile, upper quartile minus lower quartile gives you the 2.5. Again, a pretty wide range of tolerance there. So from the minimum, maximum, Q1, Q3 median that we just found by talking about those questions, you should be able to piece together that this is the box plot. All right. Last one. This one. Okay. Okay. So on this one, this one's a bit of a different one. So, and I usually get questions about it, so I wanted to go over it. So an organization collects information on the production and consumption of food and agricultural products for 200 countries. Here are 2 tables, one for meat consumption per capita in kilograms per year, and one for alcohol consumption per capita in gallons per year. Country H leads in meat consumption with 242.21 pounds. This is per capita. This per capita is like per 1,000 people, while country D is the largest alcohol consumer at 43.81 gallons. Again, that's per capita. So we're going to be using z-scores to find which country is the larger consumer, both meat and alcohol together, and really just among these 10 countries that are provided. So they do have it for 200 countries. We're just doing it for these 10. So I do know that the answer here is D, because I have my magic button on that tells me it. But let's talk about how to be able to do this. And I'm going to do this best in Excel. So I'm going to have this open up in Excel. Twiddle thumbs. Here we go. So what I need to do here, because it doesn't give us much, so this is a little bit more of a thinker here. We need to find the mean, and we need to find the standard deviation for alcohol and meat, and then we need to find the respective z-scores for each of those countries, and then we'll add them up. So I'm going to use this. I need to enable editing. All right. So I'm going to go ahead and have this find the, it froze. That's nice. It froze the top column for me, or the top row. That's cute. So I want to find the mean and the standard deviation for each of these, and we will be using the sample standard deviation. So the mean, as you recall, is average, equal average, A-V-E-R-A-G-E. We just hit aver tab. And here I can't do a column business because one, I have my mean under here, mainly because I have the mean under here. So I'm just going to do the average of just these. So notice B2 to B11, it's using the colon for the 2. And then I can use the fill. I can grab this right here, grab there's a little square in the bottom right corner, grab that and just drag to the right. And what it's going to do is notice it then just copied that formula over, but it moved instead of being the B, it's filling it over and it's doing the C's. And that's because nothing was frozen, so that column changed. All right, similarly for the standard deviation, STDEV, I want the dot S. I'm just going to arrow down, press tab, highlight alcohol, the alcohol B2 to B11, enter, and then just drag this over to fill right. So you can see the C's are done. All right. So then, now that that's done, I want to find the Z-score. We'll just do Z alcohol. I can spell today. And then Z meat. Z meat. All right, so I'm going to find the Z alcohol for country A. So to do that, I'm going to hit equal to. So we did this earlier. Open parentheses. I want country A's X value minus the mean, close the parenthesis, divided by the standard deviation. Cool. So that's that calculated. Now, I want to do that for all of these. What I'm about to do is wrong, but look what happens if I fill down. It starts yelling at me pretty quickly because I'm dividing by 0. Notice when I fill down, it is changing. It is moving what's my X, what's the mean, what's the standard deviation along with it. So there's a problem. I want my X to change because I want, notice here, this was fine because this is referencing the right X value that I want to, but my mean and standard deviation have wiggled. So I want to be able to like freeze in place the mean and standard deviation, but leave this X to be changing. So we're going to do that by freezing the formula. So I'm going to double click back into my formula. And then if you're on a real computer, you should have be able to press F4. You might, if you're on a laptop, you might have to press F F4, or if you have a keyboard with a whole bunch of weird buttons. So, but I'm going to press F4. And what it does is when you press F4, it toggles and cycles through 4 options. It sticks a $sign on these things. The first option is a $sign on both the column and the row, the B and the 13. Then it does a just on the row, and then just on the column, and then off completely. So if there's a $sign present, what that means is when I do my fill down or fill across, that thing won't change. So sometimes you might want the row to change, but not the column, or vice versa. But in this case, I don't want it to change at all for right now. Actually, in a second, I will be filling across. So actually, I'm wanting the row to not the column. Sorry, I want the row to not change. I want it to not go down. So I'm just going to keep the $sign on that 13. All right. And then I'm going to arrow over to the 14, and maybe your F4 button isn't working, so you can just literally just type in Shift-4 $sign right before the number you want to freeze, the thing you want to freeze. So now when I fill down, notice what happens. Here, this is this B5, and that's the same value. This one and those are the same value. Notice how I didn't freeze the B, because now I'm going to fill across, and I want the column to change. Okay, look what it just did there. This time, this C filled over here. So now it's pointing at C3, and that's what I want it to be. That's the meat for country B. And then it's looking at the correct mean and the correct standard deviation. So I left the C unfrozen intentionally so I could just fill to the right. So notice I just had to type in the formula once, fill down and fill across. So now lastly, I'm going to find the sums. And a little hack of mine sometimes is I'll use just empty columns just for some visual clarity, just for some little bit of breathing room. So now I want to find the sum of these. So I'm just going to do equal to, and there's two ways you could do the sum. You could type just SUM of these two things, or you could do equal to this cell plus this cell, since it's just two things. It doesn't matter, they're going to achieve the same thing. I'm just going to use the sum function. So when I fill down, you'll notice that this 0.68817 should be the same. And it is, even though now it's the sum function. Now I'm looking at the sum of these to be able to see which is the most kind of aggressive, which is the biggest. And I noticed that the biggest one is country D. So it has the biggest alcohol that we knew. It was the most unusual in terms of the greatest amount of alcohol used. It wasn't the greatest amount of meat. The greatest amount of meat went to country H, which we knew from the stem of the problem, but there's some other kind of competitors. But notice that country H, their alcohol consumption wasn't as great as country D. So when I add them together, notice that D has the biggest sum of my standard deviations. So in terms of relatively speaking, amongst all these 10 countries, country D used the most alcohol and meat collectively. So that's why we were able to answer this question here. Just minimize this. So country D is a larger consumer of both meat and alcohol, together with a combined Z-score 1.91, which is what we found here, 1.91. So now that's a lot to do that, but you see how doing it in Excel saves you a good bit of time. All right. Hour 16 minutes later. I hope this video helped. Hope you're able to jump around and find some help with this technology. And hope I was able to help answer those questions. All right, I'll see y'all in the next one. Bye.